Attempt a difference, small but finite. Physics by example. Two small balls have mass m and charge q each. They are connected by a non-conducting thread of length 2l. At some instant, the middle of the string starts moving at a constant velocity v perpendicular to the direction of the thread at the initial instant. Determine the minimum distance d between the balls. This problem exemplifies the importance of choosing a reference frame in working out a physics problem, and of course the beauty of applying principle of conservation of energy. Let us first visualize and then picture the problem. There are two balls connected by a thread. Each of them have mass m and charge q. The length of the string is given to be 2l. Now, the middle of the thread starts moving with v, and somehow that v will be maintained constant. The question is, determine the minimum distance d between the balls. What might have been happening? As soon as that middle of the string starts moving, the string starts becoming like this, and the balls keep moving from their initial positions this way. But since they carry charges, they start repelling. Of course, in the beginning itself they were repelling. That's how a tension was maintained in the string. The balls were pushing each other away, pushing each of them away from each other. But now the tensions become like this, and the balls keep approaching, but somewhere the repulsion between them stops them, and at that moment the total system, this v was maintained constant, that's given in the problem. So all these things keep moving with v because they stopped in this direction. This whole thing moves as one unit now. Many students and teachers as well, in the first attempt, try a problem like this. Of course, to be fair to them, they know that this is a problem for conservation of energy, because if you try to do it from force approach, since the angle keeps changing and the tension keeps changing, it will be mathematically a little complicated situation. So people start with energy conservation. Initially, because they hold charges like this, plus q, there is electrostatic potential energy, which is 1 by 4 pi epsilon 0 q into q by distance 2l plus ball's kinetic energy is 0, that is u1 plus k1 is equal to, now in this position balls are moving with same speed v, so we write half mv square plus half mv square plus, even now there is a distance between them, that's what we need to find out, the minimum distance. Once again there is the electrostatic potential energy 1 by 4 pi epsilon 0 q into q by d, and since this velocity v is given, mass is given, q is also given, and L is also there, so our job is to just solve this and get value for D. But when they look at the answer will be different. So where is a mistake? Look, this is where actually the idea of reference frame is going to be very, very important. when people started doing this, they've not thought seriously about where are they working from. This equation people have written thinking that knowingly or unknowingly, they're thinking that they are standing in the lab, approximated to be an initial frame of reference. So initial frame of reference is what? Its acceleration is 0. The reference frame means the person may be sitting on a body and fix some coordinate system to that, and that body, this is the body in which the person is standing and thinking of looking at the situation there. That acceleration of that is 0, which means that may be at rest or may be moving with a constant velocity. So in this case, they have thought about they thought this reference frame is at rest. Actually, they did not know it, but whether you know it or not, remember, we will be looking at a physical situation either from one reference frame or the other. Now, but the issue is slightly tricky here. When the middle of the string suddenly starts moving, you'll impart some velocities to the balls. So that was not taken into account. And actually, when the string starts moving, that develops an impulsive force on each of them, due to which the balls will jerk into motion. That we don't know how much velocity was given. So saying that the initial kinetic energy is 0 is wrong. But now there is a neat way of doing the problem. Let us draw the picture again. This is the middle of the string which is moving with V, M, M, L here, L here. Now let us choose a reference frame which is moving with a speed V, same as this is the reference frame, center of which is moving with V again. Now the person stands here and looks at the situation. Now the problem becomes at once simple and quick. When you watch from here, that means, in other words, think you are standing here. So you won't be moving, but you will put your velocities in the balls in the opposite direction like this. And at the final position also, look, at the final position also, you will be still there, and the velocity somehow was maintained, that is given in the problem. And these two balls also will be moving in the same direction with V. So for a person standing here, these balls come to rest. So the situation has become so simple now. So here the balls for him are at rest. That means their velocities are 0. These two are the velocities as you watch from here. But since this person is also having a velocity V this side, and the balls are having the same velocity in the same direction, he imposes his velocity on the balls V like this, and the velocity with reference to him will be here. You can call it U relative equals 0. That means in that reference frame the balls have come to rest. In the beginning the balls had velocities, and finally the balls have come to rest. So now, once that idea of reference frame is settled, just remaining thing is writing the equation once again, that is U1 plus K1 is equal to U2 plus K2. U1 is as usual 1 by 4 pi epsilon 0 Q into Q by 2L plus K1. Now we have got kinetic energy for the balls, that is half m V1 square, V square plus half mv square again. The balls, when he watches from here, this going this way, this going this way, therefore half mv square plus half mv square, and electrostatic potential energy because of the charges on them. So that is the initial situation. And then U2, that is d here, distance, minimum distance is d, because they are no more approaching each other, the repulsion stopped them. So that will be 1 by 4 pi epsilon 0 q into q by d plus, there's no kinetic energy for the balls now, 0. See the difference in the steps here and there. Half mv square plus half mv square went that side, actually speaking. Half mv square was coming here previously, but the half mv square business went there. So now you solve for D because everything is known. Now you look at the answer, it will be matching exactly what is given by the problem setter.